So Dr. Sam, I have made it live on YouTube and I have shared the link with you. So maybe you can refer it later on and maybe your students and your students of your university as well as the other colleges whom you are teaching. So they will take advantage out of it. And requesting you to start the class with brief your introduction and the importance of this spinal cord in neuroanatomy and how it is significant for both next exam as well as the first crop examination. Over to you, Dr. Sam.
Okay, thank you, Dr. Nurul. Thanks a lot. First of all, I would like to thank you for inviting me on this your platform for delivering the guest lecture. So I hope that this lecture will be useful and beneficial to the MBBS students who are present here also and later on also. So I am Dr. Saim Hassan. For those students who don't know me, I am Dr. Saim Hassan, working as Professor of Anatomy at SHPEP Government Medical College, Haryana. And I've been teaching anatomy since more than 12 years, for the last 12 years. And I prefer teaching students both on cadavers also, because anatomy can be best taught on cadavers, and on the lecturers side also in the LLTs. So I think I should start.
Yes, you can start, Dr. Sam.
Okay. So let me share my presentation. I'm going to share my presentation. And today we are going to discuss a very important topic of the neuroanatomy, and that is the spinal cord. So spinal cord, as you might be knowing, that it is a part of the central nervous system. So is my PowerPoint presentation visible?
Yes, it's visible.
Okay. Just I would like to, my video is coming over there.
No, your video is not coming actually. That when we tested, no, it was coming. It's mine is coming on the backdrop actually.
Yeah, yours is coming. What should I do so that my video is there?
Just hold on. Your post, just hold on. And just now you can, Dr. Sam, you can try again once. It will come, I think.
Okay.
You share your slide and let's see.
Yeah, just a minute.
Mine is again coming. I don't know. I'm just making it off. Your video is not coming on the. So let's remove it.
No problem. I can start.
There is one special request to you, Dr. Sam. Since we have committed our students that the language of instruction would be English, so I'm requesting you to use as much as Hindi you can, and all terminologies should be in English, because we have the students who would be referring later on as well as those who are joining now. They would understand better in their mother tongue. So we are, our main target students are from northern India, so they are well versed of their Hindi. So I'm requesting you that, and let's see how much you can implement, because it's very difficult to change the gear of coming from English to Hindi. But I'm requesting you to try to use Hindi as much as you can. Thank you.
No problem. I will try to use the mixed language. No problem. So, dear students, today I am going to start a very important topic of neuroanatomy, that is the spinal cord. as all of you are aware that this spinal cord is a part of the CNS. And the CNS consists of not only the spinal cord, but the brain and the spinal cord. So this spinal cord is connected to different systems of the body. It is connected by means of cranial nerves also and by means of spinal. So this spinal cord and the brain, that is the CNS, is connected by means of cranial nerves and spinal nerves. The cranial nerves that are taking their origin from the brain. So that means they are nuclei that are present within the brain. And the spinal nerves that we are more concerned in this lecture, they are taking their origin from the spinal cord. So now in this topic, in the spinal cord, we are going to see the external features of the spinal cord and the internal features of the spinal cord. And plus in the internal features, we are going to discuss the internal architecture of the spinal cord, that how this spinal cord is made up of a gray matter, which is central, and a peripheral white matter. Okay, so first of all, in the gross anatomy, we will start with the external features of the spinal cord. Okay, now मैं थोड़ा सा हिंदी में भी बोलता हूं ताकि आप लोगों को ठीक से समझ में आए. तो ये जो स्पाइनल कॉर्ड है, ये हमारा एक सेंट्रल एक्सिस बनाती है. ओके, तो ये स्पाइनल कॉर्ड, दिस इज अराउंड 45 centimeter of length in case of males and around 42 centimeter of length in females. And this spinal cord, we should know the extent also, that this is a continuation of the medulla. ये continue करती है medulla oblongata से, that is the brain stem, the lower part of the brain stem. As you know, the brain stem consists of one midbrain, pons and medulla. So this medulla, it continues into the spinal cord, downward extension of the medulla. ये नीचे continue कर जाता है foramen magnum से. Foramen magnum downwards, it continues as a spinal cord. Okay, so we take the extent of the spinal cord from the first cervical vertebrae, that is C1, or the atlas vertebrae, C1, and it extends downwards up to the L1 vertebrae. So the total extent of the spinal cord in case of adults, we are talking of the adult population, it is around from L1, from C1 to L1. And the total length of this spinal cord, is roughly 45 centimeter. It is roughly 45 centimeter. So you can see over here, it is the 45 centimeter long. Okay. Now in case of females, its length is roughly around 42 centimeter. So there is some variation in length in case of male and female. And as I told you, if you go in the fetal period, we have during the development process at around 3rd month of intrauterine life. If you start from the 3rd month, this spinal cord and the vertebral column, this spinal cord is present within, surrounded by the vertebral column. So this spinal cord and the vertebral column, they are almost similar in length. Okay, so at 3rd month of intrauterine life, I write over here, at third month of intrauterine life, the spinal cord and the vertebral column, they both lies at the L3 level, at the lower border of the L3. Okay, and subsequently what happens as the child is born and during the phases of growth. So once the child is born, it is at the level of, it is at the level of L3. Okay, when the child is born, it is at the level of L3. And subsequently what happens, the vertebral column, there is a growth of the vertebral column, and that growth of the vertebral column overshoots the growth of the spinal cord. Okay, so what happens, the spinal cord falls shorter in length as compared to the growth of the vertebral column. And you will find that the significance of this statement, that the vertebral column is shorter as compared to the spinal cord. Okay, so the vertebral column, basically vertebral column overshoots, it overshoots. So that means the spinal cord falls behind. spinal cord falls behind and the vertebral column, it overshoots the growth. It is due to the differential growth of the vertebral column. Okay, so at birth, spinal cord and vertebrae, they are of the same size lying at the level of the L3. Okay, and it stops elongated around the age 4. But we usually consider this fact while performing the lumbar puncture, because the site of the lumbar puncture is different in case of adults and in case of kids. Because you know that in case of kids, the spinal cord lies at the lower level, that is at the level of the L3, and subsequently it will shift upwards and it will reach at the level of the L1 in case of adult. So this is the short importance of the spinal cord, the length of the spinal cord in children and in adults. Now, with this spinal cord, we have a connected system of spinal nerves, and you already know that there are 31 pairs of spinal nerves, out of which there are cervical. We have 8 cervical segments, 8 cervical spinal nerves. Then we have 12 thoracic. Then we have 5 lumbar, then 5 sacral, and then the coccygeal, and the one coccygeal. So these are the pairs of the spinal nerve. And each pair of the spinal nerve exits the vertebral column at the level at which it is initially lying. Now, what happens that once during the fetal period, the spinal cord and the vertebral column, they are equal in length. Okay, so these spinal nerves, they exit out the vertebral column through the intervertebral foramen, that is almost at the same level. Okay, but subsequently what happens with the growth of the body, what happens, the course of these spinal nerves, they become oblique. Okay, because the spinal cord is falling shorter in length, and that's why the spinal nerves which were initially arising at the same level and they were exiting through the intervertebral foramen, now they are moving at the lower level and coming out through the vertebral foramen, which are at the lower level. Okay, so coming to the gross appearance of this spinal cord, it is cylindrical in shape, and it arises at the level of the foramen magnum, below the foramen magnum, that is at the level of the L1, and at the newborn, it is at the level of the L3, and it occupies upper 2/3 of the vertebral canal. Now this upper 2/3 of the vertebral canal, है ना, ऊपर है, 2/3 में है, क्यों है? क्योंकि because of the differential growth. डिफरेंशियल ग्रोथ किसकी हो रही है? डिफरेंशियल ग्रोथ जो उसकी वर्टिब्रल बॉडीज हैं, जो वर्टिब्रल उसको सराउंड करे हुए हैं स्पाइनल कॉर्ड को, उनकी डिफरेंशियल ग्रोथ हो रही है, और जो स्पाइनल कॉर्ड है वो पीछे रह गई, और इसकी जो वर्टिब्रल बॉडीज हैं उनकी ग्रोथ ज्यादा हो गई. ओके, सो इट ओनली ऑक्यूपाइज द अपर 2/3 रीजन ऑफ द वर्टिब्रल कैनाल. दिस फैक्ट वी यूज इन परफॉर्मिंग द लंबर पंक्चर. जब हम लंबर पंक्चर करते हैं तो हम इस फैक्ट को यूज करते हैं. देन वी सिलेक्ट अ साइट वेयर देयर इज ओनली द प्रेजेंस ऑफ द cistern, that is the subarachnoid space, and the spinal cord is not present at that region. Now, further details of the spinal cord, you will see that it is surrounded by meninges. Okay, as there are central nervous system, or the brain is surrounded by the meninges, that is the dura mater, arachnoid, and the pia mater. Likewise, same, the spinal cord is also surrounded by the meninges, and it consists of the cerebrospinal fluid. It consists of the cerebrospinal fluid, which is present in the subarachnoid space. Now, there is a lot of clinical and applied aspect that is associated with this presence of the CSF in the subarachnoid space, because this fact is used to perform the lumbar puncture and also to perform the spinal anesthesia. We use this CSF in the subarachnoid space for examination of the CSF in case of some viral or the bacterial, to differentiate between the viral and bacterial etiology of the meningitis. Okay, inflammation of the meninges. So in order to differentiate between the viral and the bacterial etiology, we go for the lumbar puncture. वहां से हम जाते हैं, needle insert करके हम उसका CSF वहां से निकालते हैं. किस स्पेस से निकालते हैं? जहां पर स्पाइनल कॉर्ड खत्म हो चुकी होती है. We prefer the space L3 and L4, because the spinal cord has terminated at the level of the L1. So we go in the L3 and the L4 and take out the CSF from that space. Now here in this diagram, you can see the section or the spinal cord and also you can see a number of spinal nerves that are arising. जो वहां से spinal nerves arise हो रही हैं, ये spinal nerve है जो arise हो रही है इस portion of the spinal cord से. Now you can see that this spinal nerve, ये जो spinal nerve है, now they are number of rootlets are there. These are the rootlets. All these are the rootlets. These rootlets, ये spinal cord का ये ventral aspect है, ये ventral aspect है ना. This is the ventral aspect. ये ventral aspect है spinal cord का और ये dorsal aspect है. Now how do you recognize this ventral and the dorsal aspect? Now here you should always keep in mind whenever you are looking at section of the spinal cord, then in the section of the spinal cord you have to recognize one anterior median fissure and one posterior median septum. So wherever you recognize this deep fissure, it is called as anterior median fissure. So here this is the anterior median fissure is there. This anterior median fissure is on the anterior aspect of this spinal cord, and you use this fact. आप इसी की मदद से पहचानते हैं कि हमें इसमें हमारा anterior aspect कौन सा है और posterior aspect कौन सा है, या ventral aspect कौन सा है और dorsal aspect कौन सा है. तो जिस surface पे आपको एक deep sulcus दिखता है या deep fissure दिखता है, that is called as anterior median fissure. और जहां पे आपको एक सल्कस दिखता है वो डीप नहीं होता, दैट इज कॉल्ड एज पोस्टीरियर मीडियन सल्कस. Posterior median sulcus. So there is one anterior median fissure and one posterior median sulcus. This fact you use, आप इसी fact की मदद से इसको anterior और posterior end को determine करते हैं spinal cord के. Now apart from this anterior median fissure and posterior median sulcus, there are some other sulcus also. ठीक है, वो अदर सर्कस कौन से होते हैं? वो अदर सर्कस होते हैं, कुछ एंट्रोलैटरल सर्कस होता है और एक पोस्टीरियर मीडियन सर्कस होता है और एक पोस्टीरोलैटरल सर्कस होता है. पोस्टीरियर मीडियन हमने यहाँ पर बना दिया. ऐसे ही एक सर्कस जो है वो यहाँ पर है एंटीरियरली, दिस इज कॉल्ड एज एंट्रोलैटरल सर्कस. एंटीरियरली है और लैटरली है. और एक सर्कस यहाँ पर है, ये पोस्टीरोलैटरल सर्कस है. सो दिस इज कॉल्ड एज एंट्रोलैटरल सर्कस एंड दिस इज कॉल्ड एज posterolateral sulcus. So if you are looking at the section of the spinal cord, you will find one anterior median fissure, one posterior median sulcus, and one anterolateral sulcus and one posterolateral sulcus. Okay, so very briefly, just otherwise later on we will discuss this fact that how this is made up. It has central canal and a gray matter and a central gray matter that is present. Okay, so this is a gray matter. Now what is this gray matter? ये ग्रे मैटर है और ये सेंट्रली, ये जो एच शेपेड या बटरफ्लाई शेपेड सेंटर, जब आप सेक्शन काट के देखेंगे तो आप इसको एक सेंटर में एक ग्रे मैटर मिलेगा स्पाइनल कॉर्ड के सेक्शन में. ठीक है, ये एक बटरफ्लाई, जैसे बटरफ्लाई होती है ना, वो बटरफ्लाई या एच शेपेड होता है सेंट्रल ग्रे मैटर. सो दिस इज द सेंट्रल ग्रे मैटर. एंड व्हाट इज द इंपॉर्टेंस ऑफ दिस सेंट्रल ग्रे मैटर? दैट इट कंसिस्ट ऑफ, ये जो न्यूरॉन्स हैं हमारे अंदर, इसके स्पाइनल कॉर्ड के अंदर जो न्यूरॉन्स हैं उसकी सेल बॉडीज यहाँ पर प्रेजेंट होती हैं. यानी कि उसकी जो सेल बॉडीज हैं वो जहां पर भी प्रेजेंट होगी वो उसका ग्रे मैटर बनाती है. अगर वही न्यूरॉन्स की सेल बॉडीज हमारे सीएनएस में प्रेजेंट होंगी, दैट मीन सेरिब्रम में प्रेजेंट होगी, तो वो सेरेब्रल कॉर्टेक्स का पार्ट बनाएंगी, ग्रे मैटर बनाएंगी, या सब कॉर्टिकल न्यूक्लियाई बनाएंगी. सब कॉर्टिकल न्यूक्लियाई जैसे बसल गैंग्लिया है, रेटिकुलर सिस्टम, रेटिकुलर न्यूक्लियाई है, वेस्टिबुलर न्यूक्लियाई है, जो भी सेरेब्रल कॉर्टेक्स के लिमिट्स के नीचे है, अंदर है और ग्रे मैटर है, वो वहां पर हमेशा कलेक्शन ऑफ सेल बॉडीज होगा. ऐसे ही हमारे स्पाइनल कॉर्ड में भी जहां पर भी ग्रे मैटर है वहां पर न्यूरॉन्स की सेल बॉडीज का कनेक्शन होगा, सेल बॉडीज. सो न्यूरॉन इज मेड अप ऑफ, इट इज अ नर्व सेल व्हिच इज मेड अप ऑफ अ सेल बॉडी एंड अ प्रोसेस दैट इज कॉल्ड एज axon. So wherever this cell body is present, it forms the gray matter, and wherever this axon is present, it is forming the white matter. So इसके surrounding में ये जो periphery पे है, ये क्या है? ये white matter है. ये this is the white matter. Now this white matter will always consist of the axons or fibers of this nerve cells. Okay, so just very briefly, just I want to convey in this slide that there are number of rootlets that are joining to form the anterior root or the ventral root. Okay, this is the ventral root, and posteriorly these rootlets, they are joining to form the dorsal root. Okay, so we have ventral root and a dorsal root. Here you can also see the dorsal root ganglia. This is the dorsal root ganglia, the dorsal root, ventral root, and the rootlets. Now you see these ventral rootlets, they are arising from the anterolateral sulcus. They are arising from the anterolateral sulcus, and the posterior rootlets, they are also arising from the posterolateral sulcus. Now this region of the spinal cord, which is giving rise to one pair of spinal nerves. It is giving rise to one pair of these spinal nerves. Okay. This is called as spinal segment. What it is called as? It is called as spinal segment. It is called as spinal segment. इसको spinal segment कहते हैं. ठीक है, एक spinal segment कहते हैं जो area that of the spinal cord that give rise to the spinal nerve, pair of the spinal nerve. They are called as spinal segment. Okay, is that clear? चलो अब आगे चलते हैं. Now here you can see the extent of the spinal cord. Extent of the spinal cord, that is from the C1 to the L1, surrounded by the meninges, and we are looking at two dilatations. Here there are two dilatations. One dilatation is in the cervical region. Here it is dilated, and one dilatation is in the region of lumbosacral region. Okay, that is the lumbar enlargement. Lumbar enlargement is there. Okay, so there are two enlargements, one cervical enlargement and one lumbar enlargement. I will also draw a diagram of this to show you the lumbar and the cervical enlargement. Okay, so just for the time being, अभी हम ये देखते हैं कि ये जो cervical enlargement है, ये हमें किस region में मिलता है? ये हमें मिलता है C5 to T1, C5 to T1 spinal nerves. Okay, they show from where they arise in the spinal cord, they show an enlargement. Likewise, this lumbosacral enlargement is there, that is the ventral rami of L2 to S3. L2 to S3 spinal cord segment, they form the lumbosacral plexus. Now, why the spinal cord is showing dilatation or enlargement at these two places, that we refer to as cervical enlargement and lumbar enlargement. यहाँ पर ये क्यों enlarge हो जाती है? ये यहाँ पर इस वजह से enlarge हो जाती है क्योंकि यहाँ पर ये जो वेंट्रल रेमाई है स्पाइनल कॉर्ड नर्व्स के, जो वेंट्रल रेमस है, एक तो रूट था और ये वेंट्रल रूट था, डॉर्सल रूट था, फिर वो दोनों रूट यूनाइट करके स्पाइनल नर्व बना रहे थे, और ये स्पाइनल नर्व बनने के बाद दैट वाज डिवाइडिंग इनटू वन वेंट्रल रेमस एंड वन डॉर्सल रेमस. ठीक है, इट वाज डिवाइडिंग इनटू वेंट्रल रेमस एंड आर डॉर्सल रेमस. तो ये जो वेंट्रल रेमस है, दिस वेंट्रल रेमस, they unite at these places to form some plexuses. That you know that we have the brachial plexus to supply the muscles of the upper limb, and we have lumbar plexus to supply the muscles of the lower limb. So they have to supply a large group of muscles from a very short segment of the spinal cord. Okay, so there are number of neurons present in this region because they have to supply. बहुत सारे neurons एक ही जगह पर accumulate होकर के उनको एक बड़े region को supply करना है, और वो अराइज किस रीजन से कर रहे हैं? सिर्फ वो C5 और T1 से कर रहे हैं, और उनको सप्लाई क्या करना है? उनको पूरे अपर लिम्ब का जो मस्कुलेचर है उसे सप्लाई करना है. सो दिस सप्लाईज, they enlarges spinal cord at this region, enlarges to form, give rise to the plexus that forms, supplies the upper limb. And the same happens with this lumbar plexus, that the spinal nerve at this region, that is L2 and S3, they enlarges. This spinal cord enlarges to give rise to the spinal nerves. From a short distance of the spinal cord, they have to give supply to the whole of the lower limb. Okay, so this is the importance of the cervical enlargement and the lumbosacral enlargement. Now, having said that, अब हमने ये डिस्कस कर लिया कि एक डायलिटेशन है और एक स्पाइनल कॉर्ड का एक्सटेंट है C1 से लेकर के L1 तक, और बच्चों में जो एक्सटेंट है वो C1 से लेकर के और L3 तक है, और ये जो स्पाइनल कॉर्ड है ये मेनिंजेस से कवर्ड है. अभी हम आते हैं उस पे मेनिंजेस से कैसे कवर्ड है, पर अगर अभी हम इसमें सेक्शंस देखें, अगर हम इसमें 3 डिफरेंट रीजन्स पे सेक्शंस देखें, एक हम सर्वाइकल रीजन पे सेक्शन देखें, ट्रांसफर सेक्शन, एक लंबर रीजन पे देखें, ओके, तो क्या डिफरेंस मिलेगा, और एक थोरेसिक रीजन में देखें, जस्ट लुकिंग एट द सेक्शन ऑफ द स्पाइनल कॉर्ड, ठीक है, अगर आप माइक्रोस्कोप के अंदर सेक्शन देख रहे हैं, यू विल बी एबल टू टेल दैट ये सेक्शन कौन से रीजन से लिया गया है, दैट मींस वेदर इट बिलोंग्स टू द सर्वाइकल region, whether it belongs to the thoracic region or it belongs to the lumbar region, just looking at the section. Okay, so now what you have to remember, you have to remember that in a section in the gray matter we have one dorsal horn, this is the dorsal horn or the dorsal column of the gray matter, that we also refer to as dorsal horn. Column or horn, we referred this as column or horn, so this is the dorsal horn. This is the ventral column of gray matter or ventral horn. Either you will say the complete sentence, अगर आप इसको पूरा describe करेंगे, so you will say that it is the ventral column of gray matter. Okay, ventral column. Column can be from the gray matter or from the white matter. तो सिर्फ अगर आपने ventral column कहा, तो ये indicate नहीं करेगा कि आप gray matter की बात कर रहे हैं या आप white matter की बात कर रहे हैं. तो आपको पूरा statement कहना होगा. वो पूरा स्टेटमेंट क्या है, दैट इन द सेंट्रल रीजन, सेक्शन में आप सेंट्रल पार्ट में देखेंगे तो सेंट्रल पार्ट में आपको एक ग्रे मैटर दिख रहा है, उस ग्रे मैटर का एक वेंट्रल कॉलम है या एंटीरियर कॉलम है, एक डॉर्सल कॉलम है या पोस्टीरियर कॉलम है ऑफ ग्रे मैटर, ठीक है, या हम उसको वेंट्रल हॉर्न कह सकते हैं. वेंट्रल हॉर्न कहेंगे देन वी स्पेसिफिकली आर टॉकिंग अबाउट द ग्रे मैटर. And the dorsal horn, that means we specifically are talking about the gray matter. And sometimes there is one lateral horn also. This is the lateral horn. This is the lateral horn of the gray matter. Okay, so what I want to tell you that in the thoracic region, sometimes in the section of the thoracic region, you see a lateral horn also, and this lateral horn is giving rise to the sympathetic fibers. Sympathetic fibers. So sympathetic fibers from T1 to L2. T1 to L2. तो ये जो lateral horn है कहाँ दिखेगा? ये lateral horn दिखेगा T1 से लेकर के L2 तक दिखेगा और S1 से लेकर के S3 तक दिखेगा. This lateral horn is visible in the section of the spinal cord T1 से L2 तक, S1 से S3 तक. Okay. So this is the section where lateral horn is seen. That means it belongs to the thoracic region. Thoracic region, or it may be from sacral 1 to 3 if this is visible. Now, what will be the difference between the lumbar section and in the cervical section? So what will happen if you will see this is the lumbar region or the section from the lumbar region of the spinal cord, you will find that there are a number of fibers, ascending fibers or white matter fibers that are carrying all the sensory information from the lower limbs. So number of fibers from the lower limbs, okay, in this central, in this white matter area. Now in the cervical region, you will have the fibers not only from the lower limb, but also the white matter fibers from the upper limb. So they need more space in this white matter. Okay, यहाँ पे इनको ज्यादा जगह चाहिए होती है और यहाँ पर इनको जो है थोड़ी कम जगह चाहिए क्योंकि यहाँ पे सिर्फ फाइबर्स लोअर लिम्ब से आ रहे हैं. So now you will be able to differentiate that once here they need more of this white matter. So once you will find the more of this white matter in a section, then it belongs to the cervical region, and you find less of this white matter in a section and more of a gray matter, then it belongs to the lumbar region. Okay, so this is how we differentiate between the sections of the spinal cord. Now, am I audible? Now, is it audible? Now, further continuing with the topic, okay. Now we are going to study the coverings of the spinal cord, that how they are covered by the meninges. Is everything fine at my end, Dr. Nurul?
Yes, fine. It's going on well.
Okay.
Nice
So
presentation with the, your iPad and all. So it's a good, it look like that's a physical class is happening.
okay, thank you.
Yeah.
So now we are going to discuss the coverings of the spinal cord. Coverings of the spinal cord. Okay, we have discussed the extent and the sections of the spinal cord and the segment of the spinal cord. Okay, and some of the very brief information about the introduction of the spinal cord. Now we are going to discuss the coverings of the spinal cord, how they are covered. Okay, now for that covering, I think I want to start draw something over here. I would like to draw, just a minute. Now, is my this notebook visible? So if I want to draw the coverings of the spinal cord, then you know that we have a pons. So if I want to draw the pons over here, this is the pons that I have drawn. Now this is the part of the brain stem, and this pons continues into the medulla. Now it is connected to the medulla, which is lower down in position is the medulla. Now here I want to draw the medulla. Okay, so this is the medulla that I have drawn. You have to assume now this medulla, it continues from the foramen magnum. It continues downwards. It continues downwards into the spinal cord. Okay, so it has continued downward into the spinal cord, and then it reaches at the level of the it will show some dilatation at the level of the C5 segment. It shows a dilatation. So here I have drawn a dilatation. Okay, so this is the cervical dilatation, and it continues further downwards. It continues further downwards, and it shows another dilatation, that is the lumbar dilatation. Okay, so this is the rough diagram of the spinal cord, where you have to understand that this is the pons, this is the pons, this one is the medulla. Now I have to draw a central line. Okay, so this is the medulla. This is the medulla. And this is the cervical dilatation. So it starts from here. This is the C1 level of the spinal cord, and this is the L1 level of the spinal cord. So from C1 to L1, this is just the extension of the spinal cord. Now, talking of the meninges or the covering of this spinal cord, as the brain is covered by the meninges, the spinal cord is also covered by some meninges. And what are these meninges? This is the pia, arachnoid, and the dura mater. Okay, this is in the same order as they are present in the brain. It covers the brain. So we have innermost pia mater, सबसे अंदर pia mater है, फिर इसके बाद arachnoid है और फिर dura mater है. तो अब हम इसमें pia mater बनाते हैं, और ये जो meninges है ये ऊपर CNS से कंटिन्यूअस है. दैट मींस जो ऊपर ब्रेन को कवर कर रही है meninges, वही नीचे आकर के इसको कवर कर रही हैं. Okay, so they are all continuous. So here I am drawing one meninges which is covering this brain, this spinal cord. So the innermost is the pia mater. This is the pia mater. Okay. So apart from the pia mater, it is covered by another meninges, which is the dura mater. So pia mater, then arachnoid, pia mater, then arachnoid. This is the arachnoid. This is the arachnoid. Okay, and the outermost is the dura mater, and the outermost one is the dura mater, and the outermost one is the dura mater. So these are the meninges which are covering this spinal cord, which are covering the spinal cord. Is that clear? So now what happens? What happens? Just a correction over here. This is the innermost, that is the pia mater. This pia mater is attached onto the surface of this spinal cord. So it is attached on the surface of the spinal cord. Okay. And these are attached at this level. So what I want to say is that the pia mater, which is the innermost covering of the spinal cord, which is in intimate contact with this spinal cord, this is the pia mater. Okay. This one is the arachnoid. And this one is the outermost is the dura mater. So what happens if pia mater is intimately attached to the surface of the spinal cord? It is all intimately attached everywhere. Okay. So there is one extension of the pia mater. So it is attached at this L1 level, and from this level downwards, the pia mater continues downwards. From this L1, the pia mater continues downwards as the phylum terminal, as the final terminal. So this part is the phylum terminal. So it is nothing but just the extension of the pia mater below the L1, phylum terminal. It is the extension of the pia mater below the L1 vertebrae, and it is attached to the coccyx. vertebrae. Now, another thing is that there are some modifications of the pia mater. Okay, modifications of the pia mater. One of the modification we have seen that it is forming the phylum terminal. Another important modification of the pia mater is one ligament that is linea splendens. This linea splendens, it is nothing but just the pia mater that fills this anterior median fissure. So this is the anterior median fissure. It is all filled by this anterior median fissure. It is all filled by, because it is intimately attached to this spinal cord. So this is all filled by the pia mater. Okay. So if I see in a cross section, it is filled. This is the anterior median fissure. It is filled by the pia mater. So it is called as linea splendens. Okay. So this is the first modification. Phylum terminal is the second modification of this pia mater. And the third modification of this pia mater is the posterior septum. Posterior median septum. So this is the posterior median sulcus. This one is the posterior median sulcus. Okay. It gives rise to a fenestrated band is there. And this fenestrated band is called as posterior median septum, and it is attached to the arachnoid layer. So it is the posterior median septum, which is attached to the arachnoid. So this is the third modification of the pia mater. Okay, so we have seen the modifications of the pia mater as phylum terminal, linea splendens, posterior median septum, and the fourth one is the ligamentum denticulatum. So what are these ligamentum denticulatum? They are arising from the pia mater, and they are piercing the arachnoid, and they are inserting onto the inner aspect of the dura mater. So this is called as ligamentum denticulatum. Ligamentum denticulatum. I will show you all these pictures in the PowerPoint. Denticulatum. This ligamentum denticulatum, this is 21 pairs of ligament, each tooth-like, and they are arising from the pia mater, and they are inserting onto the dura mater. So they are piercing the arachnoid, and they are inserting onto the dura mater. So they are all paired structure, tooth-like, piercing the arachnoid, and inserting onto the dura mater. There are 21 pairs. So it holds the spinal cord firmly in its place. Okay. So this is the ligamentum denticulatum. So you have to remember these four modifications of the pia mater. Number one, phylum terminal, which is nothing but just the median continuation of the pia mater downwards below the L1. And it is attached to the coccyx vertebrae. Linea splendens, which is filling up the anterior median fissure. Then the posterior median septum, another modification from the pia mater, and the last one is the ligamentum denticulatum. Now, just very briefly, I would like to tell here that here the pia matter is attached to this L1, and then extension goes downwards, it is attached to the coccyx. Now here you are seeing one dilatation because this is at the level of the S2, where the arachnoid and dura matter are attached. So the spinal cord ends at the level of the L1, but at the level of S2, the arachnoid and dura are attached. Arachnoid and dura, यहाँ पे arachnoid और dura attach होती हैं, वो नीचे आकर के attach होती हैं S2 लेवल पर. तो यहाँ पर ये जो एक स्पेस दिख रही है ना, ये जो स्पेस है, this space is called as subarachnoid cistern. ठीक है, subarachnoid cistern. यहाँ पे ये subarachnoid cistern है, यहाँ पे CSF भरा होता है. Always in the subarachnoid space there is CSF all around. So there is space showing a dilatation, and this dilatation is called as subarachnoid cistern. Okay, that contains the CSF, and we take out the CSF while performing the lumbar puncture. Now again I come back to the PowerPoint. Okay, so what we have discussed, that this is covered by the different meninges and also the terminal end of the spinal cord. The terminal end of the spinal cord, it is conical in shape. Okay, it is conical in shape. So if you remember, we have one cervical dilatation and one lumbar dilatation. So this becomes conical in shape. This conical in shape is called as conus medullaris. It is called as conus medullaris. And then there is one cauda equina also. So this cauda equina refers to the spinal nerves that are arising from the lower aspect, okay, from L2 downwards. So it will include from L2, L3, L4, L5, L6, all these spinal nerves that are emerging from this segment. And these spinal nerves, they are oblique in shape. They are oblique in shape. They are oblique in shape. Okay, they are oblique in shape. Now you remember in the initial part, I told you that in the fetal, during the fetal life, this all spinal cord and the vertebral column, it is of the same length. But as with the growth of the human body, the vertebral column has overshooted. It has grown. It has grown more in length as compared to the spinal cord. But the spinal nerves that were arising from it in the fetal life also, they were exiting out from the same level. Now, since it has grown more as compared to the spinal cord, so now they are showing the oblique curve, oblique course. So they become oblique in course and they come out from the respective foramen. Okay, they come out from the respective foramen, sacral foramina. Okay, they come out from the respective sacral foramina. But as the spinal cord it is ending at this level, so the spinal nerves, they take the oblique course, and this makes it as the looking like a horse tail. So this, because of this horse tail appearance, it is called as cauda equina. It is called as cauda equina, or it means the horse tail. Nothing but just the spinal nerves that are arising at the level of L1 downwards. So L2, L4, L5, L6, all S2, S1, S3, all these spinal nerves are included in this cauda equina. Now the phylum terminal, we have already discussed that it is nothing but it is just the modification of the pia matter. It is the modification of the pia matter which is attached at the level of the L1. Pia matter. Okay, pia matter continues downwards and it is attached to the coccygeal or the coccygeal ligament. Okay, now coming on to the next slide. So we are now coming to discuss the spinal segments, spinal nerves and the spinal segments. So you know that there is one cervical dilatation from C8, T12 and one lumbar dilatation from L1, L2, L3, L4, L5 downward based on the vertebrae where spinal nerves originate. Spinal nerves originally line up with their exit points from the cord. I told you that they originally line up with their exit point from the cord. And after the vertebral column grows much longer, each pair of spinal nerves still exits at its original location, now several segments away. Okay, so it is because of this region, because of the growth of the vertebral column, but they still exist at the same level. So what is the importance of this information? That sometimes we have to find out the level of the spinal segment. Okay, spinal segment, that whether it corresponds with the vertebral level or not. Okay, so as a general rule, in the upper cervical, we have the same spinal segment and the same vertebral level. Okay, but you will find as we go further downwards, then what will happen? The vertebral level will be less as compared to the spinal segment, spinal level. So in the lower cervical, we have the C6 segment of the spinal cord, but it corresponds with the vertebral level C5. Like in the upper thoracic, we have T5 segment of the spinal cord, but it corresponds with the T3 vertebral level. And in the lower thoracic, we have T10 level, T10 segment of the spinal cord, but it corresponds with T7. Likewise, in the lumbar, just you have to remember that this spinal cord and the vertebral level, they do not correspond because of the differential growth of the vertebral column. Okay, the vertebral column has grown, it has grown more as compared to the growth of the spinal cord, and that's why the vertebral level is less as compared to the spinal segment. Now we have discussed this dura mater, arachnoid, and the pia mater, which is an outer layer, middle layer, and the inner layer. Some modifications of the pia mater we have discussed. Okay, now here you can see the ligamentum denticulatum. This is the ligamentum denticulatum that is piercing the arachnoid, and it is surrounding. It is surrounding the ramus of the spinal nerve. So these are the three layers. Now the dura mater. The dura mater, it is a strong fibrous membrane. It encloses the spinal cord and the cauda equina. It is continuous above with the meningeal layer of the dura covering the brain. Okay. Now there is some difference in the dura mater as compared to the dura mater of the brain. In the brain we have two layers of the dura mater. In the brain, we have the meningeal layer and endosteal layer. Meningeal layer and endosteal layer. While here, in case of spinal meninges, we have only the meningeal layer. The endosteal layer is absent. Okay, so dura mater here, the endosteal layer is absent. Okay, so it ends at the level of the S2. It is separated from the wall of the vertebra by extradural space. So again, it is very important to remember here that it is separated from the wall of the vertebral canal, because here the endosteal layer is absent. It is covered by its own periosteum. The vertebral canal is covered by its own periosteum. So there is one extradural space that is above the dura mater. That is above the dura mater. It is not below the dura mater, because below the dura mater, that will be subdural space. It is above the dura mater. And what does it contain? It contains internal venous vertebral plexus and loose areolar tissue. Internal vertebral venous plexus. And what is the importance of this? Again, you will, when you are performing the lumbar puncture and you are putting the needle in the lumbar cistern to take out the CSF or to give the spinal anesthesia, then you have to pierce through this loose areolar connective tissue and the internal venous plexus in order to reach the lumbar cistern. Now the arachnoid space, below the dura mater, we have the arachnoid mater. Okay, just below the dura mater, we have subdural space, and then we have the arachnoid mater, and below the arachnoid mater, it is separated from the pia mater by the subarachnoid space that contains the CSF. So the most important thing to remember of this space is that this arachnoid matter contains subarachnoid space below this, and it is continuous above with the arachnoid matter covering the brain, and it terminates at the level of the S2. Okay, phylum terminal, you remember it is attached to the coccyx, and the arachnoid and the dura mater, I told you they are ending at the level of the S2 by forming a dilatation, and that is called as lumbar cistern. Likewise, the pia mater, it is the innermost membrane, vascular membrane. It covers the spinal cord, thickened on the either side of between the nerve root to form the ligamentum denticulatum that we have already discussed. And we have discussed not only this, but the four different modifications of the pia mater. What were these? They were the linea splendens. Then we discussed the posterior median septum. Posterior median septum was there. Then we discussed the ligamentum denticulatum. And the last one was the linea splendens, posterior median septum, ligamentum denticulatum. and there was another fourth modifications was there. Okay, so these are the 4 different modifications in the form of pia matter. Now we come on to the next slide, that is the epidural space. Now upon the dura, that means if you are going from outer aspect, you are moving inside and you want to give pierce the needle. So first of all, you will reach the epidural space. Why? Because there is a space between the vertebral body and the dura mater. Why this space is there? Because the endosteal layer is absent over here. Endosteal layer is not a part of the dura mater. Here the vertebral column has its own periosteum. So the between the dura mater and the walls of the vertebral canal, this space is called as epidural space, and it consists of loose connective tissue and the adipose tissue. And the most important aspect of this epidural space, क्या होता है इसमें epidural space में? You have heard of this space is used for giving the painless labor. So now it is audible.
Yes, audible and visible.
So epidural space, I was just telling that this is used for the painless labor. It is used for inducing the painless labor. Okay, this is for the obstetrical purpose. It induces the painless labor. We give anesthetic agent in this space, and that induces the painless labor. So this is the importance of epidural space, and this procedure is called as epidural anesthesia. This procedure is called as epidural anesthesia. इसको हम कहते हैं एपिड्यूरल एनेस्थीसिया. अच्छा, इसमें अदर भी और भी स्पेसेस होती है ना, जैसे उसके नीचे जो है वो सब ड्यूरल स्पेस है ड्यूरा मैटर के नीचे, ठीक है. ऐसे ही सब एरेक्नॉइड स्पेस है जो कि सीएसएफ भरा हुआ होता है जिसके अंदर, और इस सीएसएफ को हम स्पाइनल टैप करके इसको हम यूज करते हैं टू डिफरेंशिएट बिटवीन दी मेनिंजाइटिस, डिफरेंट इटियोलॉजी, वेदर ये बैक्टीरियल है या वायरल है, और इसको हम स्पाइनल टैप करते हैं, सीएसएफ निकालते हैं, और उसी केस में हम स्पाइनल एनेस्थीसिया भी दे सकते हैं उसी स्पेस में. We use this for giving the spinal anesthesia. अब इस spinal anesthesia की अपने varied utilities हैं, ठीक है. कोई भी लोअर लिम्ब का ऑपरेशन है, इसका पेरिनियल रीजन का ऑपरेशन है, ठीक है, और लोअर एब्डोमेन का ऑपरेशन है, हम इसमें स्पाइनल एनेस्थीसिया दे सकते हैं, इंक्लूडिंग दी सिजेरियन सेक्शन. सिजेरियन सेक्शन के अंदर भी स्पाइनल एनेस्थीसिया दे करके सिजेरियन सेक्शन करते हैं. So that is called as spinal tap, जब हम CSF विड्रॉ कर रहे होते हैं, और उसी स्पेस में हम spinal anesthesia भी दे सकते हैं. Now here in this diagram, the procedure of spinal anesthesia or the lumbar tap is explained. Both spinal anesthesia, lumbar tap, they are given in the same space. Okay, they are given in the same space. That is, you have to puncture the dura and you have to reach the subarachnoid cistern or the subarachnoid space. जैसे ही subarachnoid space में enter करते हैं, वैसे ही CSF आने लगता है. तो अगर CSF ऑब्टेन करना है तो CSF निकाल लेते हैं वहां से, और अगर उसी के साथ में हम एनेस्थेटिक एजेंट डाल दें उसी स्पेस में, तो वो हमारा स्पाइनल एनेस्थीसिया हो जाता है. तो प्रोसीजर सेम है लंबर टैप का और स्पाइनल एनेस्थीसिया का. दे हैव इट हैज अ सेम प्रोसीजर. करते कैसे हैं इसको करते हैं, फर्स्ट ऑफ ऑल यू हैव टू नो द एक्सटेंट ऑफ द स्पाइनल कॉर्ड. स्पाइनल कॉर्ड कहाँ पे एंड हो जाती है? L1 लेवल पर एंड हो जाती है. तो हम एडल्ट्स में क्या करते हैं? वी चूज द लेवल बिटवीन L3 एंड L4. ओके, L4 वर्टिब्रा को आइडेंटिफाई करते हैं. पहले कैसे आइडेंटिफाई करते हैं? वी मेक यूज ऑफ द इलियाक क्रेस्ट. इलियाक क्रेस्ट को एक्सपोज करते हैं. इलियाक क्रेस्ट का हाईएस्ट पॉइंट देखते हैं,
और जो इलियाक क्रेस्ट के दोनों तरफ के जो हाईएस्ट पॉइंट है उसको हम यूनाइट करते हैं, ज्वाइन कर देते हैं एक इमेजिनरी लाइन से। तो जिस लाइन पे हम उसको मिड लाइन में ज्वाइन करते हैं वो हमारा फोर्थ वर्टिब्रा होता है, L4। ठीक है, वो L4 वर्टिब्रा की बॉडी होती है। अब उस L4 वर्टिब्रा के नीचे हम L4 और L5 स्पेस में भी कर सकते हैं, और उस L4 वर्टिब्रा के ऊपर हम L3 और L4 में भी कर सकते हैं। ओके, क्योंकि हमारी स्पाइनल कॉर्ड जो है वो L1 लेवल पर एंड हो गई। पर बच्चों के केस में एज वी हैव टू बी एक्स्ट्रा केयरफुल, ठीक है, इन केस ऑफ किड्स, इन केस ऑफ स्मॉल चिल्ड्रन, वी यूजुअली प्रेफर बिटवीन L4 and L5. We usually prefer between L4 and, while in case of adults we can give between the L3 and L4 and L4 and L5 also. So what we do, we insert a needle from the skin, so we pierce the skin, superficial fascia, then the supraspinous ligaments, यहाँ पर कुछ supraspinous ligaments होते हैं, वो उसको pierce करते हैं। फिर कुछ interspinous ligaments होते हैं, ये interspinous ligaments होते हैं, इनको pierce करते हुए, ठीक है, we reach further downwards and we pierce the first layer as the dura mater, then we pierce the dura mater को pierce, सबसे पहले we reach the epidural space, then we pierce the dura mater, then we reach the subdural space, and then we pierce the arachnoid mater and we reach the subarachnoid space. Okay, so once in the subarachnoid space the CSF starts to come, but you have to be always keep in mind that we have to be in which region, in the region of the subarachnoid, L3, L4, or between the L4 and L5. Now we have discussed the external features of the spinal cord, the basic length and extent of the spinal cord, and also some of the coverings of the spinal cord. Now we come on to the other features of the spinal cord, that is the central gray matter. Gray matter के अंदर क्या क्या होता है, ठीक है, gray matter. So we have a central gray matter, and that gray matter, it consists of sensory and motor nuclei. ये बटरफ्लाई या एच शेपेड होता है, इसको हम सेंट्रल ग्रे मैटर कहते हैं, और उसके अराउंड में व्हाइट मैटर होता है. Like here you can see the central gray matter, and around it you can see the white matter. This is the white matter. This is the ventral aspect, so this is the fissure. It is the fissure, and this is a posterior septum. So you have to always keep this thing in mind. That
Students, there might be any interruption in the internet connection of Dr. Sayan. He is coming again. Yes, he is there. Just hold on. Just wait for a while. Dr. Sayan, can you unmute?
Now it is visible.
We are just waiting. It's not visible yet.
I am unable to share now.
Just hold on. Please share.
Okay.
Yes,
Okay.
it is visible. Yes.
Okay.
Thank you.
So just we are going to discuss the gray matter organization. Now you know that we have the dorsal horn, ventral horn that contains the motor nuclei, dorsal horn that contains the somatic visceral sensory nuclei, and the lateral horn that contains the visceral motor nuclei. Visceral motor means that is belongs to the sympathetic nervous system. Okay, sympathetic neurons are there in the lateral horn. Now, its further presentation will be based on discussing this gray matter. Okay, we will discuss this gray matter, and later on we will discuss this white matter of the spinal cord. So there's a central gray matter. I told you that this central gray matter, it consists of dorsal, ventral, and the lateral horn. And now we have a concept of Rext lamina of Rext. Okay, he gave a numerical concept to divide this region into various further areas. Starting from the dorsal horn, we have area 1, 2, 3, 4, 5, 6, 7. Then we have the area 8. Then we have a ninth area. This ninth constitutes the motor area in the ventral horn. And then around the central canal, we have then area number 10. So these are the Rext lamina. And each of these lamina, it corresponds to some of the important nuclei of neurons. Okay, so like I say that in the lamina 1, that lamina 1 consists of nucleus posterior marginalis. Okay, dorsal nucleus. Has it stopped again?
Yes, it was.
So it means that the cell bodies of the neurons that are present in this region. Okay, so cell bodies of posterior marginal neuron is present in this region. Then in the second lamina,
Requesting student to stay with us. There is a technical glitch and Dr. Sayan will come again and he will continue his lecture. Please stay with us. हाँ डॉक्टर साहब क्या हुआ कुछ इश्यू हो गया क्या? नहीं आवाज नहीं आ रहा है। हाँ, हाँ, अच्छा
हो रहा है इसमें बार बार, ये अनम्यूट क्यों हो रहा है? Now is it okay?
but your slide is not visible.
That I'm just going to do. I was continuously at for the last few minutes. I was just sharing. I thought that everything is okay.
No, अच्छा ठीक है, you just share the slide. Yes.
Okay, so what
Yes.
we have just discussed that in the dorsal horn we have sensory neurons in the dorsal horn, and those sensory neurons, they are the second order neurons that either belong to the nucleus marginalis, or they belong to the nucleus substantia gelatinosa, or they belong to the nucleus proprius, or they belongs to the Clark's column or the dorsal nucleus, or the visceral afferent nucleus that are present in the dorsal horn. They are all sensory neurons. Okay. Now the importance of all these neurons I will tell later on in the slide. That is nucleus dorsalis. Yes, this nucleus dorsalis, it is a sensory and it helps in giving rise to the posterior spinocerebellar tract. So the posterior spinocerebellar tract, it is linked visceral afferent nucleus that carries the pain perceptive fibers, and the pain from stretch receptors also from the viscera. It comes to the visceral afferent nucleus that is located in the posterior horn of the gray matter. So with each neuron, if with each cell body of the neuron, you have to remember some important thing, that this nucleus proprius, what does this proprius do? It is associated with proprioception. Okay, so the name indicates it is associated with proprioception. And what does the substantia gelatinosa? It is the pain perception. It is the pathway for the pain, touch and temperature that relays into the substantia gelatinosa. So proprius, substantia nucleus dorsalis, and visceral afferent nucleus, these are the set of neurons in the posterior horn. We have discussed these.
Dr. Sam, your voice is not coming. हेलो।
अच्छा, तो ये बार बार हो रहा है ना, ये ऐसा हो क्यों रहा है? स्लाइड मैंने शेयर कर दी। अब विजिबल हुआ?
Please unmute. Dr. Syam, could you please unmute yourself? Yes.
अब आ रहा है?
आवाज आ रही है बिल्कुल।
अच्छा, तो इससे मैं लॉग आउट कर दूं।
हाँ,
स्क्रीन शेयरिंग भी इसी से करनी पड़ेगी। मैं स्क्रीन शेयरिंग कर रहा हूँ इससे ना।
हाँ ठीक है।
जस्ट अ मिनट। इसमें मैं शेयर कैसे करूं?
ये नीचे आपको प्रॉब्लम आ रहा है क्या इसमें शेयर करने में?
नहीं, वो पावर पॉइंट कहाँ से लाऊं?
आपके मोबाइल पे है क्या वो?
मोबाइल में है।
तो उसको ओपन करिए जरा सा, और ओपन करके और फिर कनेक्ट करने की कोशिश की, वो दिखेगा फिर शेयर स्क्रीन के ऑप्शन में।
मैंने फिर से उसको उसमें एप्पल वाले टैब में ही लॉगिन किया है।
अच्छा ठीक है, बताइए।
जरा अलाउ करिए इसको।
कर रहा हूँ अभी अभी। अभी ज्वाइनिंग हो रहा है, जस्ट होल्ड ऑन, इट विल टेक 10 सेकेंड्स।
ठीक है।
ठीक है ठीक है, करिए जरा सा, जस्ट शेयर विद आईपैड।
हाँ, मैं कर रहा हूँ। आया?
Yeah, it's visible. Yes, yes. You just open this, open the presentation, PowerPoint.
आया?
No, we're just waiting, just hold on. अभी नहीं आया। Try once again, Dr. Sain, with your iPad. Requesting all students to stay with us. There is a technical glitch where Dr. Saim is facing some problem. The last 1 hour went very well, but somehow there is some technical glitches happening, and we are not able to, continue. But stay with us. We'll solve it and we'll resume the class very soon. Students, Dr. Sam is trying to log in with other device. He tried with his iPad and then iPhone, but somehow it couldn't happen. The last 1 hour, the first half went very well, and it was very good class happened so far. But somehow there is a technical malfunction is happening, so he is logging in with some other device. So till then, wait for a while. He will join within 10-15 seconds. Just wait for a while.
Am I audible now?
Yes, you are audible. And now
Am I audible?
many students joined in the meanwhile. So all are waiting for you. You just open the this and
Your voice is not coming.
what I'm saying, Dr. Sayan, you just open your PowerPoint and then try to log in. Are you facing problem in sharing the slide?
Voice is not coming to me. My voice is clear.
Your voice is clear.
My voice
Yes.
is clear.
Yes, yes.
My voice is clear. I'm unable to share my screen. Dr. Nurul, I'm unable to share my screen.
Come on, phone.
Hello.
Your voice is coming.
Okay.
You just open the PowerPoint and then try to share the screen.
So I am unable to share. Basically, I think only one screen can be shared at a time. So I think you have to give me some permission to share my screen.
I have made you a co-host, and co-host can share his screen. I'm just making you a host, and just for a moment. Are you able to share the? Hello.
Basically, desktop is not visible.
I just request you, could you please open first, keep your open your presentation and then minimize it and then try to share this.
Okay. I got it. Okay, let me do it.
Wherever, whether it's a desktop or my document, wherever a B, C, D, whatever, you just open
Yeah.
your PowerPoint, minimize it and then try to share it.
Okay. Okay.
Otherwise, you can WhatsApp me your presentation. I'll try to share from my side, and you just say next. We'll go to the next slide. Thank you.
Okay, I have opened my presentation and I have just the task.
The first 1 hour went very well actually. There is no any hiccups and no technical glitch.
Is there any limitation for the timings in the Zoom?
No, not at all. It is for 24 hours. It's
Okay.
It's business account actually.
Okay. Now I have opened my presentation.
And then in the bottom there is a green icon is coming, share screen.
Share screen is there.
Yeah, you just click it and then
now it is coming. Okay.
and
Your
now
internet connection is unstable.
you try to find your presentation that there is a
I have find it. It is coming on the computer screen.
yes. Yes.
Okay. Is it visible now?
Just hold on. Somehow, yes, it's visible.
Okay. Now I think everything will go fine.
Yes. Whatever is left, we'll take it in the next, maybe in the next Sunday or next Sunday. Let's see with other, because Dr. Parag was scheduled. Maybe I'll schedule your class and we'll take her class later on.
Okay, no problem. No problem. I will try to finish it. Otherwise, if it is not possible, we will continue in the next. Okay.
Now next class will start from say 2 o'clock. So we can take till 1:30.
Okay. Starting. So this was the slide that I was discussing. I think everything will go fine now. So we have already discussed the organization of this gray matter, the central gray matter of the spinal cord. And now you know that this central gray matter is divided into various horns, that is dorsal, ventral, and lateral horn, and consisting of the sensory neurons at the dorsal horn and a number of motor neurons in the ventral horn. What is important here to understand is that this consists of cell body of neurons. This consists of cell bodies of neurons, as we have a different number of ascending and descending tracts in the spinal cord. So these neurons that participate in this ascending and descending tracts, they have cell bodies over here. They have cell bodies over. For example, if we take an example of some sensory pathway like the pain, touch, or temperature. So these sensory neurons from this touch, pain, or temperature, they have their they arise, the point of origin is from the skin. If suppose we have to carry the touch or the pain, so the receptors for touch and the pain are present in the skin. So a neuron takes this touch and the pain from the skin, and a single neuron reaches from the spinal nerve. It travels via the spinal nerve and it reaches up to the central spinal cord. So the cell body of the neuron is present over here. That is the dorsal root ganglia. So it is giving one peripheral process that is going into the spinal nerve. The cell body is over here, and one central process. Now this first order neuron will come in the gray matter, and over here it will synapse. It will synapse with the second order neuron, which is present in the substantia gelatinosa.
Okay, and in this way, the substantia gelatinosa, either it will further synapse, or this second order neuron, it will ascend up, and it will ascend it up to different level of the spinal cord and terminate at a higher level, and then it will synapse with the third order neuron to take this pain sensation to the higher centers in the brain stem. So we were discussing this substantia gelatinosa. We have discussed this nucleus dorsalis. This is to take the posterior spinocerebellar tract. So this takes the nucleus dorsalis. It takes the sensory fibers that are going in the spinocerebellar tract. So the spinocerebellar tract is an ascending pathway that takes the sensations from the muscle spindles, the tendon organs, and they carries the proprioception from here to the cerebellum that helps to maintain the posture and balance. Okay, so this the function of the cerebellum is to maintain the posture and balance, and it is also helpful in maintaining the unconscious proprioception. Unconscious proprioception. By unconscious proprioceptions, we mean that we are able to maintain our posture, though we are not aware of it. And this is the function of the posterior spinocerebellar tract, which is taking this modality of sensation via the nucleus dorsalis or the second order neuron to the cerebellum. Likewise, we have visceral afferent nucleus, and that visceral afferent nucleus is for the visceral afferents of pain that are arising from the viscera within the abdomen, or viscera that may be an organ like the liver or spleen or kidney, and the pain from those organs, they are carried by the visceral afferent fibers, and they carry it to this visceral afferent nucleus, which is present in the rex lamina 7. Likewise, we have substantia gelatinosa. It is associated with the modalities of pain, touch, and temperature, and they are distributed throughout the length of the spinal cord. And the nucleus proprius, which is again related anterior to the substantia gelatinosa, extends throughout the length of the spinal cord, and it is concerned with the proprioception. So we have discussed the neurons that are sensory in nature, that are present in the dorsal column. Now we will be discussing the neurons, that is the second order neurons, that are present in the central, this gray matter, ventral gray matter. Okay, so the ventral gray matter, it consists of the neurons that innervates the limb muscles, that is the lower limb muscle. We have a lateral group for the lower limb muscles, and a medial group for the upper limb muscles, and a central group. This central group of neurons in the ventral gray horn, the central group will innervate it will arise from C1 to C5. That means it will be present in the cervical segment C1 to C5, where it will innervate the diaphragm. It innervates the diaphragm. Likewise, from C3 to C5, it has a nucleus that innervates the sternocleidomastoid muscle and the trapezius muscle. So we have a nucleus to innervate the diaphragm, or called as phrenic nucleus, that is located between C1 to C5, or we have a nucleus here to innervate the sternocleidomastoid and trapezius muscle, that is to innervate the sternocleidomastoid and trapezius muscle, and another nucleus, which is a dorsal lateral nucleus, that it innervates some of the unknown muscles. So the ventral horn, it has 3 different nuclei: medial, lateral, and the central one. Now coming on to the white matter fibers, white matter of this central spinal cord, white matter. Now what happens if you see closely, here we have the white matter that consists of in the form of funiculus, because it has to form some tracts, and these tracts are present in these white matter. We call these tracts as funiculus, we call these as tracts or funiculus, or we call as lemniscus. It all means the same thing, that is the axons of the neurons, So in the anterior part, we have axons that are forming the descending tracts. Okay, in the posterior column of white matter, we have axons that are forming the ascending tracts, and in the lateral column of the white matter, we have both the ascending and the descending tracts that are forming the ascending and descending tracts. So we have white column over here, white column, and the lateral column, and this is the ventral or the anterior column. Now we have different tracts in these columns. So now we are coming to the tracks. So first of all, we will discuss the ascending tracks. Ascending tracks. So what are these ascending tracks? These ascending tracks are those that are concerned with carrying the modalities of sensation. Those sensation modalities can be pain, touch, temperature, pressure, vibration, or it can be the sense of position, or it can be balance. They are all carried by these ascending tracks. So the named tracks, the name of these tracks are, in the posterior column, we have the fasciculus gracilis and fasciculus cuneatus. Fasciculus is the similar meaning for the tract. And this tract consists of the fibers, the neurons or axons that have a similar origin, and they have a termination at the same level, and they carries the same modality of the sensation. So together they group as the tracts or the fasciculus. So in the posterior column, we have fasciculus gracilis and cuneatus, and these carry the modalities of position, vibration, touch, pressure, and proprioception. Also, it carries the discrimination, discriminatory touch, as we are able to differentiate between the 2-point and the 2-point touch and the deep touch. So this all modalities are carried by the posterior column. Okay, posterior column. Now the sense of proprioception. Proprioception. What is proprioception? Again, this is responsible for conscious proprioception. This fasciculus gracilis and cuneatus, they are responsible for conscious proprioception, while these spinocerebellar, which are the dorsal and the ventral spinocerebellar tract, they are responsible for unconscious proprioception. By proprioception, we means the information is coming from the joint position. That means the fibers, they are carrying the position from the joint position, or from the muscles, or from the muscle spindles or joint, or from the ligaments or capsules of the joint. And it enables us. Hello?
We are on the slide number 29 is visible. Are you correlating what you are delivering? Because the slide is 29, it's not moving actually.
Okay, let me see. Now is it moving?
No, it's still 29. Slide number 2, organization of white matters, 3 columns on each side.
The organization of white matter. Okay, now it is not moving. Okay, does it change?
It doesn't.
No, still no.
No, it's a freeze actually. It's not moving ahead.
Okay, otherwise my voice is coming.
Yeah, your voice is coming. Otherwise, Dr. Sain, because the best way of teaching was in the iPad, and it was very, going great actually at that time. But somehow we are not correlating. So we'll do one thing. We'll keep your lecture till we are covering the CNS, and then we'll request the other, lecturer to join the next classes. So
okay, no problem. Okay,
no problem. Next class we have Dr. Paravos. I request her to to take the class later on, and your class will be continued in the next class.
Okay, fine. That is better also to take on the iPad.
Yes.
So that I can use my.
So I'm announcing all the students that you will join again on because we have already announced the schedule, but we make changes in that, and I request Dr. Farah that she will take the class later on, so that your topic will be covered completely. In the
next. No problem.
I'm just announcing it, since my voice is not coming to you through Zoom, so I'm just announcing. Yeah.
Okay. Thank you.
So all the
नहीं हो पा रहा, क्या कहते हैं, रिले नहीं हो पा रहा यहाँ से.
So all the students, those who were there till 12:10, it was going very nice, and Dr. Saim was teaching with his iPad, and it was very, it looks like that we are into the physical class and we are with his in classroom actually. But Dr. Saim, the slide is moving now, but here we are Dr. Sam, the slide is moving now. So, but what we are doing that we'll take the same class of Dr. Sam on.
Hello. Hello.
Dr. Sam was trying to call me on phone. Somehow it get disconnected. So it's already 12:53. So we are, calling off this class and we'll take the same class on next Sunday. That is on 30th of August, on the same time at 11 a.m. And the announced class of Dr. Faragos would be taken on the next, that is on 13th of August, I think. So we'll take the class on 30th of July. Dr. Sam voice is not coming. He's not able to listen through this Zoom app. His voice is coming through phone only. So thanks, Dr. Sam, for sparing your precious time and teaching very important topic of spinal cord. We'll continue with the same topic with the left out things which we would be covering in next class. So we are signing off and we are joining again. I'm keeping this Zoom on actually, but I am putting my keeping on microphone off and camera off. And we'll join at 2 o'clock again with Dr. Gohar Hassan will take class on physiology, cardiovascular physiology. It's a very important topic. And I am requesting all the students who join from Government College Mewar, they come again or stay with us. They can just keep your device mute and keep your camera off. We'll join again at 2 o'clock when Dr. Gohar Hussain will take the class on cardiovascular physiology. Thank you.
Okay, thank you.
ठीक है डॉक्टर साहब
ओके डॉक्टर साहब ठीक है ओके
ठीक है नेक्स्ट करते हैं मैं उसको जो हमारा बैनर है ना उसको एडिट करके दोबारा फ्लैश कर दूंगा सबको मिल